Okay, welcome to the last view for Unit 3, which should take about 4 periods, and then we'll move on to Unit 4. So this one's about impulse, as you can get from the learning intention, which was be able to explain and apply impulse and momentum, including force versus time graphs. I know you've done impulse in the past. So impulse is the change in momentum. Okay, and very easily derived. We already know that F equals ma. We know that A equals delta V on delta T. So if we do a very simple substitution, so we end up with just an easy F equals m delta V over delta T, and if you rearrange it, you just end up with F delta T equals m delta V, which is exactly how we talk about impulse. And you can see on the left hand side is the F delta T, and if you look at that, that would be Newton seconds. The right hand side would be kilograms metre seconds to minus 1. They are the same. You get marks, you get 4 marks for using either one, but it would be normally nicer to actually use the one that you actually use the units, depending on the version that you actually use to derive the answer. Now, why is it used? It's particularly used for situations like collisions. So you'll get questions like, how do you reduce the force? And it's obvious, like all other equation type bases, reduce the force by that. If that's available, of course, less mass, less velocity, and or more time. So, and that would be particularly in collisions, things like airbags, because an airbag is simply designed to actually make a collision last longer, which seems kind of counterproductive, but if you make it last longer, it reduces the actual force. Okay, second half. It was a very short video. So, force versus time graphs. In any linear equation, such as impulse equals F delta T, if you've got any linear relationship with two quantities, like this one, the area of the graph is the quantity, or in this case is the impulse. So whatever the actual subject of the equation is, any graph of two quantities in a linear relationship, automatically the area is the quantity we're talking about, or the actual like impulse in this case. So it means that if we have a force versus time graph, no matter what the shape, and if you get an example that you have to calculate, it's going to be an easy shape. So, area area equals the impulse. Okay. Now that's a conclusion of that one. We'll follow that up obviously in class with a variety of questions and some exam questions, and then we'll move on to the next one, which is going to be about work done.